importance of individual organisms rather than types. And recognizing that variation is exactly what we expect out of populations. And the variation is inherited from one generation to the next. And although the variation might change because of differential reproduction due to interaction with the environment and various fitness of the different variation we see as natural selection, we still can explain the variation we see in one population from populations that preceded it. And we expect to see that variation persist in various ways. Soon after that paper was published, Willy Hennig's work became popular in the US. Willy Hennig was a German entomologist. And he introduced the notion of cladistics, or phylogenetics, or tree thinking. And whereas, is that better? Okay, good. If that happens again, just tell me. Okay. So, where Ernst Mayr really challenged the idea of typology and typological thinking, to the point where some people think he actually invented a straw man. We'll leave that aside. Willy Hennig challenged the way we think about similarity and what it means for two different species or taxa. Taxa might be groups of species too. What it means for taxa to be related to one another, or what it even means to be a taxa or belong to a taxa. And he argued, look, if we're going to take Darwinian evolution seriously, then what we need to do is we need to track the history of these taxa, and we need to group things together by virtue of common ancestry, not by virtue of some notion of similarity. Similarity in and of itself is a kind of empty claim. Any two things can be similar to each other. You can find similarities between anything. What matters is relevant similarity. And what Hennig argued is that systematists, that is, people who are trying to describe the natural world and explain the diversity, they ought to recognize, insofar as similarity is relevant, it's similarity by common descent, by relatedness. So, this is taken from his famous book. This is an interesting diagram to try to interpret. And there's been lots of debates about how to interpret it. But what we're looking at the tips, the black circles are extant taxa, or extant species. And what he argued is, look, what we need to do is we need to infer the history of how those things evolve, what the phylogenetic relations are between those species. And then we're going to group those species in what are called monophyletic groups, or clades. Where a clade is an ancestor, so number 2, for example, and all and only its descendants. So number 2 is an ancestral species that has a whole bunch of descendants. And what it means is, things over here are all more closely related to all the things over here than to anything over there. And it's a pretty simple idea. And it's a pretty intuitive idea, and it's a really nice way to capture evolution and the pattern of common descent. But it's still pretty controversial. Okay, so why is it controversial? Well, it tells us what taxa are. If taxa are just collections of closely related things, then it challenges a lot of long-held ideas. And one very famous one, and one that there's an interesting generational divide on. So depending on how old you are, you either learn that dinosaurs are reptiles, or you learn that dinosaurs are birds. Now I could give a whole talk on that. But on a phylogenetic view, birds are dinosaurs. The reason being, this is birds, this is the bird taxa here. So this is where all the birds are. And they're more closely related to all these dinosaurs than they are to anything else. If you go down here, you find crocodiles. Down here, you start finding other things like snakes and lizards. So birds are much more closely related to dinosaurs than they are to any kind of living reptile. So that's why paleontologists today, in many ways, I guess we'll find out tomorrow what Mark thinks, pretty much all argue that birds are dinosaurs. If they disagree with that, they may disagree with it because they don't think that phylogenetic tree is correct. not because they're not committed to phylogenetics. All right. Now, one thing that phylogeneticists like to point out is that it's a rejection of teleology. So again, this is from David Baum on a paper on tree thinking. And what he's doing is, this paper is a really nice paper that teaches, it's meant to teach undergraduates about tree thinking or phylogenetic thinking. And one thing he emphasizes is that, look, we typically put people at the ends of our trees, as though that was the end product of evolution. That's where things were going. But these two trees are identical in the relationships that they hypothesize between the various species. I mean, there's no reason to put humans at the top of these things. And there's all kinds of trees you can go and search and find humans smack dab in the middle. Before I had this one, I had a really horrible slide of a butterfly phylogeny that includes includes mammals, but it's buried deep in there, and it's actually very difficult to find them in mammals, which I like. I think that's a big truth. So it forces us to rethink our place in the history of life. All right. So those are the modes of thinking I want to at least use to set the table. Embodying all those, I think, is what's called the individuality thesis. So Mike Giesland is a sea slug anatomist at the Cal Academy of Sciences. He's a Utah grad. He grew up here. I think his dad was a chemistry professor, I think. Someone might correct me on that if I'm mistaken. And David Hull is a philosopher of biology. In many ways, Hull founded the modern field of philosophy of biology. And Hull and Giesland worked very closely together on advocating for the individuality thesis. So Giesland was a postdoc of Ernst Mayer's and won a MacArthur Fellowship for a book he wrote about Darwin. And in that book, and then in subsequent papers, he argued that we should think about species not as sets or classes or abstract objects, but as individuals, as concrete individuals. And I'll try to explain what that thesis means a little more in just a moment. And David Hull initially was hesitant to adopt this view, but eventually came around and became a major advocate for it. So you have a biologist, Michael Giesland, and a philosopher, David Hull, working together on promoting a metaphysical thesis in the biological literature. So Hull was an editor of Systematic Zoology, which is now Systematic Biology, which was a hugely important journal at the time, and still one of the major journals in biology. And they're writing philosophical papers in the biological journals, which is really great. And that's one reason why Hull is the founder of contemporary philosophy of biology. He really established a precedent that if you're going to do good work in philosophy of biology, it ought to be something that has some relevance to what biologists are doing. Otherwise, you're just a philosopher interested in biology. Okay. So this impacts practice of systematics. And I'll explain how that happens in a slide in a few minutes. But it's a real challenge to both typology and teleology, and how we think about who we are. All right. So the term individual, the term set, and the term classes, those are all technical terms in philosophy. And I think they're actually a bit misleading. So there's been lots of ways of articulating the individuality thesis. Some of those are more helpful, some of them not as helpful. So here's one characterization the law philosophers find helpful. So species are, and apologize for reading when I know you all can read, species are spatio-temporal entities located in a genealogical nexus as opposed to abstract sets or classes of objects. Right. Sets, clear as mud. So let's try switching that up a little bit. I like to think of this as a claim that species are historical entities or historical objects, meaning they're concrete things that have a beginning and an end, just like we do, and that they're defined by ancestry or history rather than any intrinsic properties that they have. This ends up being a pretty radical view. So remember, Aristotle's characterization of natural kinds, which has persisted into the 20th century. So natural kinds, the two things I mentioned before, is that we're supposed to take species as paradigms of what natural kinds are. And the natural kinds are defined by essential properties. Well, we've got a dilemma. That doesn't work if species are historical objects that don't have essential properties. So either we have to jettison species from the category of natural kinds, or we have to radically revise what we think natural kinds are. Now, people have done both. I'm going to ignore revising natural kinds. I actually don't think we need to revise the notion of natural kinds. I think it works just fine. It just doesn't work well for species. And we've discovered that. That's a major discovery. This has upset a lot of philosophers because for 2,000 years, species have been taken as paradigmatic natural kinds, and suddenly, oh, whoops, it turns out they're not. Oops. A lot of them have now gone to the table of elements. I'm actually suspicious that that's going to turn out well for them also. That's a separate story. So, what do we do then if species aren't natural kinds, but they're individuals or historical objects? Okay, this is the worst slide I have because there's too much stuff on here. I'm going to walk you through it. Well, if species are individuals as opposed to natural kinds, that has a major impact on how systematists and biologists think about what species are. So individuals don't have members. Natural kinds or classes or sets have members. And they have members because those members possess properties that are defining them as that kind of thing. All right, so we check whether something belongs to a natural kind or a set by checking to see whether they have properties. So if I was going to check to see whether you were members of some natural kind, I would examine you and see if you had the property that defined that natural kind. But that's not how individuals work. Individuals are concrete objects that have parts. So it's a part-whole relation. It's a physical thing. In physical things, we often think of an individual as an organism. And an organism is certainly one type of individual, but it's not the only type of individual. So our solar system is an individual solar system, but it's spread out over a lot of space. But being spread out doesn't necessarily mean you're not an individual. One way to be an individual is to be really tightly packed together. But we need to be a little careful that we don't anchor this to our particular view. Because from our perspective, that's pretty solid. I'm not just showing up. It's strong.